Good morning, ladies and gentlemen of calculus. We're going to go over this quiz we just had, and here we have what is the limit as x approaches 4 from the left of f of x. So we go over here, what is that going to be equal to?
4.
Looks like 4, right? And as we approach 4 from the right, it'll be same, right? And what is the limit as x approaches 4 of fx? Since these are the same, we know our answer is also 4. And what is f of 4?
1.
Looks like 1.
Wow, Mr. G, I got this right. You should be proud of me because I've been messing up on this all the time. I got those right, team.
Excellent, excellent. Did everybody get these right?
So far.
All right, excellent. Good.
4 for 4.
4 for 4. That's awesome work. All right, let's go on to the next portion. If g of x continuous at x equals 3, justify your answer. So what I would do here is I'd say limit as x approaches 3 from the left side of g of x equals limit as x approaches 3 from the right side of g of x. Another thing is we have the 3 conditions, and we know that this exists, right?
Yes.
And it's going to be actually equal to the left side. So we have that. So we're going to just have to figure out if the limit exists. And so we plug in 3. So we get on the left side 2 times 3 minus 1 equals, we have 2 squared plus 2. I'm getting 5 is equal to 6. Is that right? Is that, no, I got it wrong.
Wrong.
5 equals 11.
You're
Yeah,
rude.
5 equals 11.
Yeah, I put the wrong number
Not
here.
equal to
Yeah, so 3 squared plus 2. It ends up still being the same thing. Do they equal each other? No. Okay, since, okay, so now the justification. Since limit as x approaches 3 of g of x, what we put down does not exist, g of x is not continuous at x equals 3. Okay, everybody get that?
C.
How are you? Were you good on having were you good at the explanation like this too? Did you have that on there? Like this? Okay, good. Okay. Go to the last 3 here. What is integral from 1 to 6, 4 dx? What is this going to be?
20.
Should be 20, because we actually have this thing here, y equals 4 in between 1 and 6. So you have a 4 by 5 rectangle whose area is 20. All right. Next, we have this one here. What did you get for this one?
I don't want to be wrong.
I don't want to be
Negative 1/5.
negative 1/5.
Okay, you know, so sorry. I actually said something out loud. Negative 1/5.
Good job, Hannah.
I got balls.
Oh, thank you. That will be our video. Our audience will love to hear
You
that.
got it.
They know.
Maddie, Hannah, balls.
Maddie probably seen them.
All right. Actually, these things will be viewed occasionally.
It's Carson's dipole.
I've heard worse. Okay.
I think everyone's heard this.
Yeah, it's true.
It's a messed up
Okay.
world, Mr. G.
This, it's true, Harry, you're right. What did you get for this one?
I said that it doesn't exist. whenever I did it, whenever I plugged 2 in, just like that, it got 4 over 0. But whenever it branched it,
Yeah,
whenever I
this
branched
is
the
a-
bottom one out.
This does not exist, and why is that?
That's all.
Because the bottom of it is always equal to 0.
Yeah, so what we have is we're gonna have 4 over 0 when we plug in. And so we're not gonna have 0 over
Oh, so
0.
it doesn't even equal each other, you're right.
Yeah, so this is gonna be an example of does not exist,
Nice.
okay?
Here you go.
How many got 100% on this one?
8.
No, I didn't have time.
Didn't have enough time
I
for
just
it?
missed 2 of them.
Oh, yeah, well, beautiful, good
Number
job.
6.
Good job, guys,
I got one,
good
two,
job.
three, four,
Yeah,
five.
That's what I did.
Yeah, I did.
She did perfect.
Like it?
No, I didn't like it that much.
I didn't
Because
either.
people talk over each other.
They act like children
I just thought it
and
was
argue, just like, it'd
Yeah,
be so much
That's
better
true,
if you
Gavin.
both look at.
I'd like to see what debates were like.
The one thing I thought of for the next debate is if the microphone could be controlled, right? Like, okay, now, Mr. Vice President, here's your 2 minutes, and then you turn off all other mics, and you give him 2 minutes.
Yeah, that would be great.
Okay, Mr. President, now your turn, turn off the other mic.
One thing that I can see would be wrong with that is if it turned into a screaming match at that point.
Yeah, it could go that way.
I could imagine that happening.
It possibly could, yeah, but,
I'd like
But-
to see debates in the 1800s.
yeah. Well, the thing about it is
Like
that
Abraham
people
Lincoln.
were kind of,
That way you just shut up, man.
7 years ago or whatever.
If they spoke like that, I'd be more interested.
a lot of people are talking about that this is really contentious political time, and it is, but it used to be a lot worse. Andrew Jackson was
Andrew Jackson.
really
Forrest.
something. Yeah, well, yeah, he would challenge people to duels and stuff like that.
To duels?
Yeah.
He would just cast.
In fact, he was injured in a duel, not when he was president, but before he was president, he was injured
I
in a
think we should
duel.
bring the duels back.
I think so.
I think we should do it. There needs to be like a court.
Well, you have them now, they're kind of on Twitter, they are duels now, sort of. Okay, we're gonna go to,
Or nothing like deadly though.
Can I get
Like a knife throw.
okay. Here we go,
Not
what's
necessarily
that?
guns, but like knives. It's like
Oh, yeah, sorry.
Here's a machine gun.
Me, the average mode.
Literally bring a knife to it.
Range, subtract from the largest,
A rail gun.
medium, and over.
Brick shoulder.
Here we go.
I have a song about me.
Destination we need to go.
Okay,
The concept of railgun is also terrifying.
ladies and gentlemen, let's bring it back. We're glad that you're active citizens, concerned citizens, everything like that.
Mr. G, would you ever want a rail gun? Just to play around with?
A real gun?
A rail gun.
A rail gun?
Yeah.
Yeah, but I would just,
Just
Never
casually.
heard happening this on naval ship.
okay. So, what happens is, if a function is continuous on an interval that is closed like this from A to B and differentiable on that interval, there exists a number C from A to B such that f prime of C equals f of B minus f of A over B minus A. So this is what this is going to be. This is going to be instantaneous rate of change is equal to average rate of change. So I rock equals A rock. And we talked about
That's my new nickname.
what you have to have is we have to be continuous and differentiable on the interval, which means the entire interval. So if anything breaks continuity or differentiability between A and B, the mean value theorem does not apply.
Fun.
All right? So verbally, yeah, graphically, where the tangent line is parallel to the secant line. So what that is, if you have a function like this, if you have a function like this, and you have two points here at A and B, and between these 2 points, there is a secant line joining those 2 points, right?
Yeah.
And so the slope of that secant line is going to be, there is going to be on the line a tangent line that is exactly parallel, that has the same slope. So here's your average rate of change, the slope of that secant line, and the IROC is the actual touching at the point of tangency. Okay, you see that? So it has to happen. But you can see that if you don't have the mean value theorem, this is a smooth curve in between. There are no, it's differentiable, no holes, also no sharp corners or anything like that, right? No vertical tangent lines, nothing that's a break, nothing that would disqualify. And so that would happen. So that's the mean value theorem. And sometimes, well, we're going to apply it right here. So this ties back what we had on our quiz the other day. We had a average rate of change problem. Thank you for reminding me. Average rate of change problem. And so this is where we tie average rate of change to instantaneous rate of change. And so what we have is this problem 1. Let f be the function. Find the number c that satisfies the conclusion of the mean value theorem. If we go back here, I'm going to put this right here. Remember, we moved this thing right up here and touched right here. So what that means is right here at x equals c, there is a value c where this instantaneous rate of change equals the average rate of change. Okay? So that's at x equals c. And so that's exactly what we're looking for, we're looking at in this first problem. So I want you to go, typically what you'll do is you'll find the average rate of change over this interval, and then you'll take the first derivative of that, and what will you do with of this function? If you find the first derivative, what will you do? Well, just go work ahead on this. We'll show you how it works out. Go ahead and find the average rate of change.
I think I did it.
You found the average rate of change? Okay, well, we'll go over a minute. Find yourself an average rate of change on this. I would put like A, B. So this is what I'm looking at for an average rate of change. Does that look good?
Wouldn't f of 3 be 12?
I might have made a mistake on this. This is going to be 6. Yeah, it's going to be 12. Yeah, I made an arithmetic error. Thank you for correcting that. So that's going to be 12 minus 0, so that's going to be 6, right?
See, Mr. G, I got 6, but I did not do that.
Really? What did you do? Do it.
I just,
Yeah, that's it. You did what it was.
Well, you just put it in a big, you just
Yeah,
put
I
it in a
just
big
did one
formula.
big
Okay, yeah. So you did one big thing.
so I
You did
didn't give you
this.
that.
Yeah, you
Yeah,
did
you
it,
really
but
did.
just,
Okay,
you didn't break it up into steps like I did.
yeah, I just,
Anyway, so now what we have, what is going to be f prime of x?
f prime of x is gonna be 3x squared.
3x squared minus 7. Okay, now here we have, what are we going to do next with this thing?
Yeah.
Trying to find where, where,
We're kind of.
Wouldn't you just make it equal to 6?
Yeah.
I could be wrong.
all right, here, what you'll do is you take this thing right here and you go and replace this thing right here
Oh.
with 6. So you have 6 is equal to 3x squared minus 7.
That's what Aaron just said.
Is that what you said?
So it's gonna be 13
So 13
equals
equals 3x squared.
15 square root of 13 divided by 13.
So we get 13 divided by 3 equals x squared. So what is x equal to? X is equal to plus or minus 13 over 3. Or square root of 13 over 3, right? So
That's fine.
what is going to be the value, what is going to be the number c?
That plus or minus.
No,
No, it's not.
you got to look back here, right? What is going to be c? Okay, look back here. What is c going to be?
It's going to be between those.
Yeah. So what is it going to be?
What's it gonna be?
Is that what you said, it was 2? Between numbers? I'm confused. Is that not what you just said? And you said yes?
You're not people are not understanding me, obviously. Okay.
Wait, hold on. Let me find out.
That's what I was asking. Okay, that's fine.
Okay, we have two possible solutions here, right?
So it can't be the negative one.
Yeah.
So it cannot be -1, so it has to be
2.549.
this one here, provided it's between 1 and 3, and it better be because what?
Yes, it's 2.5.
Because it satisfies, what tells you we've satisfied the mean value theorem?
Oh,
How do you know, remember what the conditions of the mean value theorem, how do we know the conditions of the mean value theorem are met? Okay, let's look at this right here. What do you have to be? What do you have to have? You have to have the function be continuous and differentiable. So the question is this thing continuous and differentiable on this interval?
yes.
How do you know that?
We don't know. I just know it is.
Okay, the reason you know that is because this is what kind of a function?
Oh, it's what's it called?
It's like,
It's not
it's in my head, but
Yeah.
it's not real.
What kind of function is this?
No. Come on.
What kind of function is this?
Quadratic function.
The cubic. That's what it is.
It is a cubic function, and a cubic function is part of the larger family of
Oh, what is it?
Is it Russell?
No, it's
Starts with a P.
Polynomial.
power.
Polynomial function.
Polynomial.
Okay, and polynomial functions, by definition, are going to be either a line or a smooth curve. Meaning that what? You're going to be continuous and differentiable. So just the very nature of the function tells us we met these conditions. And then we go work out, and this is typical of how you'd work it out. You find an average rate of change, put it in place of f prime of x, solve for x, and then you're going to have your, then you have to look back and see, well, this one here, square root of, when you think about that, that's going to be a little bit bigger than 4, right? And the square root of 4 is 2, so it's going to be a little bit over 2, which makes sense, right?
Yeah.
I don't know in the calculator if you found the decimal version, but then you look and you check and say, yeah, does that check out? Yeah, that checks out. So this is going to be our answer right here.
It's like 2.1.
Yeah, 2.1 something. Okay.
2.08.
So as you go through these things, you just kind of think, does this make sense? Does what we're doing, does that all make sense? Okay. Okay. Let's go to the next one. And here's our next one. And this is a calculator one. We have let f be the function defined by fx equals x plus lnx. What is value c for its integer rate up? F at x equals c is the same as the average rate of change over 1 to 4. Is this going to be a continuous and differentiable function?
Yes.
How do we know that?
Because it's a, what's that called? Natural log?
Yeah, we have a natural log and an x which is polynomial. So we have a combination of a polynomial and natural log function. And we know this x is going to be continuous and differentiable what? Where?
What was the question?
Where is f of x equals x continuous and differentiable?
Everywhere.
Everywhere, right?
Everywhere.
What about Lnx? Where is Lnx continuous and differentiable?
I'm gonna go, is that everywhere?
No.
I forget what a natural
Yeah,
log
it'd be
is.
all positive
All
numbers.
positive
Okay? And then you say, okay, well, so yeah, that's where, and so in the combination, this is going to be continuous and differentiable for x is greater than 0. And then you look at, you say, well, what is the interval we're given?
Greater than 0.
This is within greater than 0. These are closed intervals. And so we meet those conditions of continuity and differentiability. And so now you can go about the process of, and you can use your calculator for this.
I forgot to do natural log.
Well, there's a key in your calculator.
This is the ln, right?
It's ln.
It's underneath log.
Underneath that?
Log.
ln.
Oh, yeah.
And it's one of the functions we went over in pre-calculus last year. That was one of the parent functions of pre-calculus we did. I don't know if you remember back that far. That was before the pandemic interruption and everything.
First C. I got it. For the 1.5.
See, the way I would do this is I'd put x plus ln x, and here's one value. This is f of b, right? And then one storage x, and then we have x plus ln x. And here we have f of a. So f of b minus f of a over b minus a.
I got,
Now, so you put, it'll be like 4 point, right?
oh, 1.4.
4.3863, we'll say, divided by 3, is that right? Because 4 minus 1. So here is your average rate of change. Is that what you got?
Yeah.
And what I recommend doing when you're doing these problems, make sure you're out to at least 4 decimal places if you can be. It's 1.4621. Okay. And then, what do we do with this thing here? Find f prime of x. What's f prime of x going to be? You don't even know this one. I didn't even tell you this one
How
yet.
about just 1
It's 1.
plus, oh, in that, doesn't it just say the
The
same?
derivative of ln
It's
x
just the same thing.
is, no, it's going to be 1 over x.
1 over it.
And I haven't shown you that one yet. So what you do is you take this
Instead of equal.
and set this equal. So you take 1.4621 is equal to 1 plus 1 over x.
So wouldn't x just equal the?
Well, what you do is,
Oh, you'd have to,
yeah, you have to subtract 1, so you get 0.4621 is equal to 1 over x.
and then
So
you gotta-
x is equal to 1 over 0.4621, which equals
2.169.
2.164.
9.
Oh, I always have to do the wrong thing. Huh. I see.
2.164.
Yeah.
And so, so that's going to be C, right? C is equal to 2.164. And then we check to see, is that between 1 and 4? Yes, and it better be, because it's, what, if you found that it was not equal, it was not between 1 and 4, what would that mean?
You did it wrong.
Probably did it wrong, probably made a mistake in the equation or some solution or something like that. Okay, so that's that one. And then I think we're going to go right into the a table view, and we have differentiable, find a positive number that must exist value. And so what this is it's taking f double prime, which is the second derivative, for greater than 0, and yeah, I want to come back to this after we get into our second derivatives and all that. But I want to go into Rolle's theorem today, which is 17. Rolle's theorem, if you look at Rolle's theorem and look back at note card 16, do you see similarities?
The continuous and differentiable.
Yeah, continuous and differentiable. And what else? Okay, here's what Rolle's theorem is. You have to have f of a equal to f of b.
Oh,
And if f of a equals f of b, then you have a point. So what this is, for Rolle's theorem, it looks like this. So I'm going to take this function here like this, and we're going to say A is right here and B is right here. What we have is we have f of A equal to f of B. So that means we have a horizontal secant line. And if we have a horizontal secant line, what does that mean? It means we're going to have a value C right here whose slope is 0. So this is really what this is a special case of the mean value theorem. It's the same thing, but in this special case where you have a horizontal tangent line, that's what it is. And so that's why we're doing it like we are. We're looking at mean value theorem with Rolle's theorem right on the heels of it, because really you don't have to specifically mention Rolle's theorem, because Rolle's theorem is part of the family of mean value theorem. It's like a special case of the mean value theorem. Does that make sense? So anyway, what you're looking for in these, you're looking for if f of B equals f of A. If so, find C. So go ahead and find, do we have continuity and differentiability here?
Yes,
Yes, and we know that because?
it's a polynomial function.
Well, it's because of polynomial function, exactly. And how do we know that f of B equals f of A?
Because it's like even.
Yeah, like even, right? So you're going to get f of 2 is going to be equal to 2 to the 4th minus 2 squared, which is going to be the same as negative 2 to the 4th minus 2 times negative 2 squared. Okay, so they're the same. So f of B equals f of A, so it says if so, find C. So I want you to find C. And by the way, since f of B equals f of A, Rolle's theorem applies. So I want you to go ahead and find C. Still in class. What is f prime of x going to be?
4
Minus,
4.
and what do we set this equal to?
Settle.
Set it equal to 0 because that's what we find, right? And what is our common factor here?
4x.
4x. So we have x squared minus, is that 1? Yeah. So we have 0 is equal to 4x, and we have x plus 1, x minus 1. So do we have C? So C is equal to what?
All kinds of different things.
All kinds of stuff, which is
0.
0. And what else?
-1.
Negative 1, 1. So that's what C equals to. And if you go ahead and graph that in the calculator,
Yes, put it in.
so we got x to the fourth. We got x to the fourth minus, is it 4x squared? So we graph this thing here, zoom 6.
Oh,
And so we
yes.
see we have, well, we shouldn't get, there's something wrong here. Yeah, there's something messed up then. Minus 2x squared. Yeah, I put in the wrong equation is what it amounts to. Minus 2x squared. Yeah, I put 4x squared. Okay, now it's going to be right.
Oh, I didn't even notice that.
He didn't, yeah, I didn't notice either. I noticed it didn't really turn. So now it looks right. Here's your horizontal tangent line, horizontal, horizontal. Yeah.
Nah.
But see, that's the cool thing about in calculus, you can look at it